In this video, we're going to try and find the derivative of sine of x. So given y equals sine of x, what is dy by dx? Okay, and from some of the earlier videos, we proved these identities here. But in order for us to find the derivative of sine of x, we're going to need this one here. So later on, we're going to use this identity here. Okay, and also from our section on limits, I need you to accept this, that in our section on limits, we did a lot of work on this. The limit of this thing here as x tends to 0 is 0, and we did lots and lots of work on this one here. And also this one here, the limit of this as x approaches 0 is 1, and again we've done lots and lots of work on this one here. So here I'm going to have to I'm going to have to assume that you understand these two here. Okay, if not, then go back to our section on limits. Okay, so to find out the derivative of sine of x, first we need to sketch our graph here. Okay, so start by sketching your graph y equals sine of x, and it will be something like this. And then set up 2 points A and B, and then take the limit as h here tends to 0. So the true gradient exists when you start to take the limit as h tends to 0 of this thing here. Okay, and just like us finding out the derivative of y equals x squared here, we would set up 2 points A and B, and then form ourselves a right angled triangle underneath, and then get h to tend to 0. It's the same process here. Okay, so the true gradient exists. Well, the true gradient is the limit as you take the limit as h tends to 0. Okay, so once you're here, and this bit here is when we start to use this identity here. Hang on, we are now using this identity here. So this here is in a way our x. Okay, this here is our h. So whenever you have sine of one thing plus another thing, you can just immediately jump to this. Okay, so remember, sine alpha cos beta, and then cos alpha sine beta. So if you can't remember it, write it down somewhere. Okay, so we're going to use this now. So we're just going to extract this bit here. So this bit here, hang on. So whenever you have sine of one thing plus another thing, you can immediately jump to this. Okay, so this whole thing here is this bit here. Okay, and then you've got yourself a minus here, and you've got yourself a minus here, so that's this minus here, and this block here is this block here. Okay, so everything's the same, it's just that this whole thing here becomes this here. Okay, and then our next step, so at the moment you've got one block plus another block, take away this block here. So we're going to switch these blocks around. Okay, so this one goes over here. So basically now this one here remains the same, that's this one here, and then this one here. So remember, the minus belongs to this. So now you've got minus sine of x. So this block here is this block here, and then this one here, this block here is this block here. Okay, so we're just switching these two around. So our next step. Remember that at the moment we're taking the limit of this whole thing here. Okay, and then this thing here then becomes this, and now we're going to break this fraction up into two separate fractions. So it's like this. Okay, so at the moment we are here at the moment, so we're going to break this fraction up. So it's like one fraction plus another fraction, because look, same denominator, same denominator. So when you add the two together, it will give you this. So we're just breaking up the two fractions. Okay. Yeah. So that will then become this here, and then our next step is to you see, looking at this block here, you've got sine of x. Sine of x is in common. Sine of x is in common. Factor out the sine of x. So well, factor out the sine of x. That will become this, because if you get this times this and then this times this, it will give you this. So we are just working backwards. We are factoring out sine of x. So that will give us this. Okay. So so now this would then become this, because think of it as one block multiplying a fraction. So when you multiply a fraction, it gets multiplied to the top. So it's the same as this anyway. So my point is that this whole thing here becomes this here. Okay, and then the same with over here. So visualize this as, hang on. So visualize this as one block multiplying with another fraction here. So this one gets multiplied to the top. That will then give you this. Okay, so this whole thing here becomes this thing here. Okay, and then our next step, what's our next step? Hang on, let me think. Oh yeah, our next step is at the moment you've got one massive block here. Hang on, you've got one big block here. Because they're multiplying each other, so that becomes a block. You've got a plus here, so it gets separated. So you've got this so at the moment you've got one massive block plus another massive block. So remember when you there's a theorem that says if you take the limit of a plus b, if you try and take the limit, that you can actually break into this. So the limit of this whole thing here is the limit of a plus the limit of b. So what it's saying is rather than finding out the limit of the whole complicated thing here, you can just concentrate on finding out the limit of a and then add it to the limit of b. So at the moment, hang on, at the moment you've got this complicated thing here plus this thing here. So you can just concentrate on finding out the limit of this thing here, and then finding out the limit of this thing here. Okay, so rather than finding out the limit of the whole thing here, rather than finding out the limit of this whole thing here, just concentrate on finding out the limit of this, and then on a separate occasion find the limit of this, and then add the two together. So concentrate on finding out the limit of this, and then add it to the limit of this. Okay, so that would then give you yeah. So this here, this is independent of h. So remember, you're trying to find out the limit as h tends to 0, but this thing here doesn't really contain h, so you can actually take it out. So concentrate on finding out the limit of this, and the same goes over here. You're trying to find out the limit as h tends to 0. This here doesn't really contain h, so you can actually take it out here. Okay, and then just concentrate on finding out the limit of this. Oh, by the way, this here is as h tends to 0. I forgot. Sorry. So from here, just concentrate on finding out the limit of this. Okay, and then concentrate on finding out the limit of this. Now, from our section on limits, this has to be ingrained inside your mind here. The limit of this here is 0. The limit of this here is 1. So that's this one here. So now it's sine of x times 0. So this goes, leaving you 1 times. So the derivative of sine of x is just cos of x. So the derivative of this thing here, sine of x, is just cos of x. So when you look at the graph, hang on. So when you look at the graph here, look at the red line. The red line is sine of x. The blue line is cos of x. Now, looking at the red line, looking at this sine of x graph, when you are here, you can see that the gradient here is 0. So now the blue line, remember hang on, let's start again. The red line, looking at the red line here, the gradient here is 0. And look at the blue line here, it is 0. So the gradient here is 0. Okay. Now if you move slightly to the right, here you can see the gradient is negative, and it's the gradient's a low negative. Looking at this here, hang on. Looking at this here, you can see the gradient is negative because look, negative, and it's quite shallow. But as you reach over here, the gradient is really steep, and it's negatively steep. So look now jumping to the blue line, that then you see the gradient here is 0, and that corresponds to the 0 mark here. Looking at this bit here, looking at this bit here, you can see the gradient is negative, and it's it's a low negative. Looking at this point here, you can see the gradient here is positive, and looking at this point here, you can see the gradient is positive. And if you move down here, you can see that the gradient itself, the blue line is indicating that it has a positive gradient. Looking at this point here, let's say this point here, okay, the sine of x, you can see that the gradient here is negative, and then so this point here, you can see the gradient is negative, but moving straight up here, the blue line indicates that it's negative. Okay, so looking at these two graphs, you can actually see that this the derivative of sine of x is cos of x. Okay, it tallies up, it matches up. Okay.